God, we thank you so much for today. I pray for Israel and Michael that you would help them to understand this lesson, and for Fabi and Gabby, wow. Fabi and Gabby and Emma, Lord, that you would bless them as they study this difficult work. Lord, help us not to be rushed through today, but instead to accomplish everything that you want us to get done. In Jesus' name, amen. Okay, so today we're going to talk about asymptotes of rational functions. So they want horizontal and vertical asymptotes. So how do we find a horizontal asymptote? Horizontal asymptotes are the ones at the very ends. So these are these functions that like you have this kind of thing going on, right? And then you have like stuff like that, like weird things, right? So these are your horizontal asymptotes. And this guy. Sometimes they're the same at positive infinity and negative infinity, sometimes they're not. So you have to be careful. But that's this guy. How do you find a horizontal asymptote? It's actually pretty like easy, but also like mind-blowing. You take the limit for this guy, you take the limit as x approaches infinity of your function. And of this guy, you take the limit as x approaches negative infinity of this guy. And if that gives you a number, then you have a horizontal asymptote like this. If it gives you a function, or if it gives you infinity, then you have a slant asymptote, which I believe is for, this lesson. So if we get a number, then we graph y equals that number. If you get infinity, you have to do ugly things, okay? Which it appears as if you will have in this lesson. Biblical perspective, you can kind of get a feel for where your life's going to go, right? You can get a feel for it, like spiritually, right? Like you can see how the patterns in your life are playing out. You can see how the things that you're doing, like do they lead you closer to Christ? Do they lead you away from Christ? I was talking with the teachers yesterday, and we were talking about how like mentors in our life and like people who were influential, like some of them have gone off the deep end now and like aren't following the Lord anymore, and how some of them are so close to the Lord. And it's like, you're like, but these guys were following Christ. They were doing everything right. They had all the right things, right? But like, you know in your heart, what things am I doing that are drawing me closer? What things am I doing that are drawing me away from the Lord, right? And so it's kind of sobering, because you look at that and you're like, what's going to happen at the end? Okay? So just a thought there for you guys. So let's try one with the simple asymptote, and we will go from there. All right. So for this one, they just want you to write the equation of the horizontal asymptote. Okay, so how do we find the horizontal asymptote? Take the limit as x approaches infinity of that, and you get what? So when you plug in infinity to this, what do you get? You get infinity to the fourth over infinity to the fifth. Which one takes over? Yep. So you have something over a bigger number, which equals 0. Now, if you don't believe me, you could go, well, Belinda, last lesson we learned that if you get infinity over infinity, then you do L'Hopital's rule and take the derivative, right? You could totally do that. Take the derivative of the top, take the derivative of the bottom, eventually you'll get that it goes to 0. Now, let's try the limit at negative infinity. What do you get? So if you plug in negative infinity here, you get negative infinity to the fourth, which is just infinity, over negative infinity to the fifth, which is negative infinity, because it's an odd power. So you get negative 0. Are we bothered? No. Your horizontal asymptote is y equals 0. So at the end, this function will go towards 0. If you look at the graph in your book, you see that, right? Over here it goes to 0, over there it goes to 0. Right? Over here it goes to 0, over here it goes to 0. Right? Viewing audience out. They don't make you. But you could, I mean, you could plug it into your calculator. Now, that was just a really hard one because the zeros are hard to find. So let's try this guy. So now we're going to graph y equals negative 5x plus x squared over 2x squared minus 8. Okay, how do we find the horizontal asymptotes? It's right there. Yeah, you take the limit at infinity. So what is the limit as x approaches infinity of? So what's your highest power term on top? X what? X to what power? X squared. What's your highest power on the bottom? So the answer is 1/2. So it's 1 divided by 2.
I think you want to look to the
First term? No, the highest term. Because that term's not going to take over. This one is. Because you have infinity squared, right? That's a big deal. Okay. If you want, you could do L'Hopital's, right? Because you have infinity over infinity. So you get the limit as x approaches infinity of, take the derivative of this, you get minus 5 plus 2x over 4x. Still have infinity over infinity. You could do L'Hopital's again, you get 2 over 4, which is 1/2. So this is not enough to do our asymptote. We also have to do what? What's the other piece? What's the other piece? Look over there.
Plug in the limit x equals x to negative infinity.
Good. So this gives us the right end of our graph. This gives us the left side. Yep. What's weird about the negative infinity? You just have to look for odd powers. They'll mess things up. But we only look at the highest power, so x squared. When we square negative infinity, we get positive. When we square negative infinity there, we get positive, so this is still 1/2. So our horizontal asymptote is y equals 1/2. Okay, is that all we need to graph it? Nope. What other things do we need for our graphs? We need zeros, which come from this. And we need our vertical asymptotes that come from this. So let's factor these. This is x, negative 5 plus x over 2x minus 2x plus 2. Yes? Maybe? Of course you're going to say yes, but why? If you factor out 2, you get x squared minus 4. It's the difference of squares. Here, if you factor out x, you get x times negative 5 plus x. So, what do we know about this graph? Number 1, we have a horizontal asymptote. Here, we have zeros where? Give me one of my zeros. Where'd you get 1 from? So if it's 0, then x would be 0. And what's the other 0? So Israel used this one. What's the other 0, Michael? So if I plug in 2, I get 0.
Oh, yeah, oh, yeah. You
So if
just
I
don't
plug in
know
negative
the
5, this is
derivative
0?
of each side.
I forgot
Oh,
something. I forgot
0 and
the
5.
thing.
Or,
I forgot you.
5, 0. Because x is 5, y is 0. Okay?
I
So
forgot.
those are our zeros. Now we have to do asymptotes.
Oh, yeah.
What are our vertical asymptotes? When these are 0. When is this 0, Israel? So what is the equation of my asymptote going to be? What equals 2?
Did you get 13?
It's not a trick question. You got this, buddy. X equals 2, right? Because it's a vertical line, so it should be x equals. Our horizontal line is y equals.
Oh.
So what about this one? X equals what?
Well, okay, so.
-2.
Negative 2. So now, in order to graph this, I'm going to put all of this information together.
And then V is.
Okay. So here's my graph.
D.
Here's my x-axis, my y-axis. I need.
And then what's, see, I always forget the integral for that.
1/2.
Okay, I know my zeros are at 0 and 5, so I have to go a little bit further. Okay, I use that one. This one is 0, 0. Vertical asymptotes at 2 and negative 2. Horizontal asymptote at y equals 1/2.
Trying to do that.
Okay, so we are never, ever, ever allowed to cross these lines. So, how do I graph this function? At infinity, I knew that I was approaching 1/2. Was I approaching it from the top or from the bottom?
I just kind of think I guess. How was it supposed to do that? I thought you know.
So, if I'm approaching it from the top, then it would go this way. Do I have any chance of going through that 0? No. So it's going to be from the bottom. You can always plug in numbers. So like if I didn't know, I could plug in 10 and see what I get, right? Negative 50 plus 100 is 50 over 2 times 100 minus 8. So I have 50 over 198. So that's a little bit less than, or 98.
Wait, what you times it? 2 times 150, oh,
Oh,
So 200
let's
minus
see.
8.
Negative 5 times 10 plus 100. That's 50. We have 2 times 100 minus 8. So that's like 0.26. It's like a quarter. So I know it's got to be below here. So you can always put in points. So what I'm going to do is I'm going to connect these dots here. That goes to my horizontal asymptote. This goes down. Now when I go down, I have to start at the. We have a problem, don't we?
And that equals 1 plus 3.
Okay.
We have a big problem. We have a really big problem. I said you weren't allowed to cross those, huh?
Well, I think you said don't try to.
Then you saw.
I just crossed it.
And 0.
You plugged in 1 and 0.
So the horizontal asymptote only really matters
Just feel like when we
at the ends.
when we-
So you can cross it in the middle.
The next one I did.
Okay. Now if I'm coming down, I'm going to start at the top.
Yeah, well, what did you get when you
If you have a calculator, great, use it to check. If not, do your best guess. Okay? So that's our horizontal asymptote. Notice that this one, Israel, come back. You got this. I know it's really exciting. Really, it's like riveting. You're like, whoa, so cool, right? And you're like, man, that's awesome. Okay, this horizontal asymptote, notice it's not at 0. You've never had them not at 0 before. So, that's that. Is that the whole lesson? No, it gets worse. Okay, so let's graph this one. Forgot my jacket today, so I'm gonna be cold all day. I don't like being cold. It's not good. X squared plus 1 over x. Okay, so 3 things. We have to do horizontal, or we have to do end behavior, which could be our horizontal asymptotes or our slant asymptotes. We don't know yet. We have to find zeros, and then we need vertical asymptotes. Okay, so what are the zeros? Is the top ever going to be equal to 0? Why not?
Because one of the,
Yeah, like you can't solve that and set it equal to 0, right? It's never going to work. So there are no zeros. My function is never, ever, ever, ever equal to 0. Is that okay? Yeah, that's fine. Because x squared is always going to be 0 or a positive number. Plus 1, that'll never be 0. What about our vertical asymptotes? What makes the bottom 0, Israel? X equals? When is the bottom 0?
If all x is infinity.
When x equals 0. Because this part will be 0 if x is 0.
Oh,
Okay. Now, let's get to the hard part. So what do we do with end behavior? Well, again, we do the limit as x approaches infinity of our function. What does this equal? Does it equal 1? Does this equal 1? Michael says yes. Israel?
yes, because
Well, let's check. How do we check?
plug it in.
So we have infinity over infinity, which means we can use from yesterday L'Hopital's rule. So what would the new top be, Israel? What's the derivative of 2x plus 1?
2x.
What's the derivative of x, Michael?
Half.
Derivative of x. Bring down the power, subtract 1. So you get 1 x to the 0, which is 1. What's the limit as x approaches infinity of 2x over 1? Infinity. So if you get infinity here, then you know you have a slant asymptote, which means that it's not going to go to a horizontal line like this. It's going to go to a slant. What is that slant? Well, the way we find the slant asymptote is we are going to divide these. Okay, you must divide. So we're going to do x squared plus 1. This one's easy, so you really don't have to do the division, but is that true? Yeah. So what does this tell us? This tells us that our function is going to follow x at really big numbers. Why? Because when I plug in infinity to this term goes away, and I'm left with x. Think that through for a second. If I divide this out and I plug in, because this x plus 1 over x is the same as this. Right down. Absolutely the same. So at infinity, this term goes away because 1 divided by a big number is 0. And so our function is going to follow x. So what is my slant asymptote? Y equals x. So what is my function going to look like? It's going to look like this. So we have our graph. I'm going to write out all my asymptotes. So I have a vertical asymptote at x equals 0. I have a slant asymptote, y equals x. You guys remember slant asymptotes? If you divide your function, you get the slant asymptote. It's that part. Now you know. Okay, here's our question. Does it go here, or does it go here? Do we have any zeros? No, so our function will never be 0. Therefore, it will live up here. Once it goes up in asymptote, it has to start from the bottom. And so that's your graph. We knew it wasn't in this part. We knew it wasn't this one. Because we would have zeros. That would be x squared minus 1 over x. You also know that it's this blue one because you're going to x, but you're adding a little bit. So it should be slightly above the line. Okay, that's your lesson. You may be